Okay, so quick refresher on the things we've been talking about. First, slopes. Remember, that's just a way to describe something's steepness. And if a slope was running uphill, when you read it from left to right, remember that's a positive slope. If it's running downhill, you got yourself a negative slope. A slope, we represent it with the letter M. It's the rise over the run. And if you do a slope formula, that's it right there. Because rises are the y's, they go up and down. X's run side to side, that's the run. And you just want the difference in those y's over the difference in those x's. So we've been talking about several ways of just finding slope. If you have a graph and everything's counting off by ones, you might as well just say it's going to be the rise over the run. And let me just write that up here. Just look at the picture. I'm definitely running uphill from left to right. And I'm just counting. 1, 2, 3, 4 for the rise, 1 for the run. The slope of that thing is a positive 4. Okay, this one definitely running downhill from left to right. So no, it's going to be negative. If I count rises, run, 1, 2, 3, 4 for the rise, 2 for the run. The slope's -2 once I reduce it down. Okay, but just practicing up using the slope formula, like the 2 points in here, it's -3, -3. Hang on. Excuse me. So there's -3, -3. This is the point -2, 1. So if I use those 2 points, I've got a first point, second point. First x, second x. First y, second y. So if I'd done this with the slope formula, second y minus the first y over the second x minus the first x. That turns to 1 plus 3. Here's -2 plus 3. I get 4 over 1, same slope. I mean, it has to be the same slope, but same line. But it's just practicing up with the formula. Like this is the point, let's see, 1, 2, 3, 4, 1, 2, 3. This is the point -4, 3. This is -2, -1. Okay. So -4, 3, -2, -1. First x, second x, first y, second y. So if I do the second y minus the first y, second x minus the first x, I'm going to end up with -4 over 2, which is -2, same slope. You can work it both ways. It's important to be able to do it both ways. Sometimes you have a graph and it's easier just to count. Sometimes you don't. And you know the coordinates of the points or of 2 points on the line. And that's going to be the easier way. Okay. And then we figured out during our last class, if you can graph a line, if it's in slope intercept form, which is y equals mx plus b, where m is the slope and b is the y-intercept. Okay, so if you had y equals 5/3 x plus 3, this thing has a slope of 5/3. It has a y-intercept of +3. Okay, so we're going to have these little whiteboards that I bought. We're going to use those. We're going to practice up drawing some lines. And you don't have this next page. This is just so I can put it up here and we can check our work. But y equals 4/3 x minus 2. That's the first one we're going to graph. So remember, start at the y-intercept. Y-intercept's -2. So on the y-axis, go -2. Slope is rise over run. So from that point, we're going to rise 4. 1, 2, 3, 4, run 3. 1, 2, 3. Do it again. Rise 4, run 3. Rise 4, run 3. So going up 4, right 3 is basically the same thing as going down 4, back 3. 2, 3, 4, 1, 2, 3. And then remember, that's the only points we put on there ourselves were the, like I put the point 9, 10 on there. I put the point 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 6 on there. I put the 0.32 on there. Like those are just simple integer values that made this work. We call those lattice points where both coordinates are integers. But when I draw in the entire line, that represents every single ordered pair that would make this true. And a good way of checking this, like if you want to make sure that you graphed your lines in the right place, because we're going to have a quiz on Wednesday, take one of those points that you just discovered and plug it into this equation. So if I do 4/3 of 9 and take 2 away, okay, 39 is 3. We're seeing if this is true or not. 4 times 3 is 12 minus 2. It is. So if x is 9, y is 10, and both sides equal the same thing. Okay? All right, so this one, we got a y-intercept of 1. I'm going to rise -2, run +5. So I'm going to go down 2, 1, 2, 3, 4, 5, right 5, down 2, 1, 2, 3, 4, 5, right 5. Or I could go up 2, 2, 3, 4, 5, back 2, up 2, back 5, sorry. 1, 2, 3, 4, 5. And then I'm going to sketch in every single ordered pair that makes it true. So like I looked at it as the rise was -2/5. I could have looked at it as the rise is +2/5, which is what happened when I went in reverse. Okay. All right. If you can't make a fraction out of, or if the slope's not written as a fraction, make it a fraction. All numbers can be written over 1. So then I've got a y-intercept of 3. I'm going to go down 4. 1, 2, 3, 4, right 1. 1, 2, 3, 4, right 1. 1, 2, 3, 4, right 1. Or I could go up 4, back 1. And this will represent all the ordered pairs that make that true. Okay, if you don't see a number in front of that x, it's a 1. To make it rise over run, make it 1/1. I've got a y-intercept of -4. 1, 2, 3, 4. And I'm going to rise 1, run 1. Rise 1, run 1. Rise 1, run 1. But again, if you're like, ooh, quiz time on Wednesday, here's the point 10, 1, 2, 3, 4, 5, 6. What if I plug that up here? Is the y 6 when the x is 10? Oops. Well, it sure is. 6 does equal 10 minus 4. Then you feel really good about the fact that you put it in the right place. Okay, remember the y-intercept's the b on the end plus 0. If there's not a number getting added, it's always 0. So rise 1, run 3. Rise 1, run 3. Rise 1, run 3. Or else go down 1, back 3. Down 1, back 3. Down 1, back 3. There's that one. This one, you got, I should have made one of those negative. Oh, well. So, oh gosh, what did I put plus 1, plus 0. So we got a y-intercept of 0, rise 1, run 1. There's that one. Okay, so you were doing all those on your whiteboards, but there they all were again. The only thing we haven't talked about as far as drawing a line is a horizontal and a vertical line. So first, let's talk about a horizontal line. Here's an example one, definitely a horizontal line. If I just start writing the points for this, like this is the point 0, -1. Here's, let's see, 1, -1. Here's 2, -1. Here's 3, -1. Here's 4, -1. If I come back this way, here's -1, -1, -2, -1, -3, -1, -4, -1. It's like, what do they all have in common? That's pretty simple. Every single y value is -1. So guess what the equation of this line is? Yep, it is y equals -1. Now, if you want to make, because looking at that graph, that is a function. It passes the vertical line test. So, and it is linear. So by what we've been saying, this could be written in the form y equals 0. Oh, sorry, I'm jumping the gun. Y equals mx plus b. But here's the thing, there are no x's up here. So it's 0x, and then the y-intercept's -1. So it'd be 0x minus 1, which means the slope of a horizontal line is 0. Slope of a horizontal line is 0. Big time. That's important. And you can see it too. If you pick points on here, like let's say we pick this one and this one. To get from one to the other, rise over run. Well, there is no rise, but there's a run of 1, 2, 3, 4. Slope 0. If I were to do the slope formula using those 2 points, remember second y minus the first y all over the second x minus the first x. So what 2 points did I pick? -4, -1, and 0, -1. Okay, so second y is -1, first y is -1, second x, first x. -1 plus 1, 0 plus 4, 0 over 4 gives you 0. Because 0 divided by a number is just 0. So slope of a horizontal line is 0. Now, here's the thing. A vertical line, not a function. Because it does not pass that vertical line test. Like if I drew a vertical line, it crosses it infinitely many times. Not a function. Therefore, it does not have to look like that. Because that was our definition of a linear function. It was any line or function who could be written in the form y equals mx plus b, where m and b were both constants. Well, that's not happening here, but we could look at the points on this one and see what's going on. This is the point -3 up nothing. This is -3 up 1, -3 up 2, -3 up 3, -3 up 4, -3 down 1, -3 down 2, -3 down 3, -4, oops, sorry, -3 down 4. What do they all have in common? Oh, look, every single x value is -3. But if you were to do the slope, and you were looking for rise over run, if I just pick 2 random spots on here, say right there and right here, and I counted, I got all kinds of rise, 1, 2, 3, 4, but I don't have any run. And that is undefined because we can't divide by 0. Okay, so the slope of a vertical line is undefined. That's big. And if I were to do the slope formula using those 2 points I just picked, or any 2 points on the line, it wouldn't matter. I picked what? -3, 3, and -3, -1. So second y minus the first y, second x minus the first x. You get -4 over 0, which is undefined. You can't divide by 0. Okay, so just, can you see why we never refer to a vertical line as a function of x? Yeah, because for every input, I do not get one and only one output. I get infinitely many outputs. Okay, so when you're graphing these horizontal and vertical lines, they're real easy to spot. There's only going to be just a y, or there's just going to be an x. There's never going to be both. If there's a y and an x and it's a line, it's going to have some kind of slant to it. But so it's just, I want all the y's to be -3. Well, all the y's being -3 sit right there. I want all the x's to be 7. 1, 2, 3, 4, 5, 6, 7. There's all the x's being 7. Okay, so if it's a y equals a constant, it's horizontal line. X equals a constant, vertical line. And then, so we say, oh, what's the slope of y equals 2? That's a horizontal line running through up there at 2. 0. This is a vertical line running through back here at -4. that slope is undefined. Okay?